Okay, today we're going to go over 1-6, solving absolute value equations and inequalities. Absolute value is a number's distance from 0 on the number line and is represented by these two little bars here. What these two little bars do is they take whatever number's inside of them and make it positive. So, let's do an example. The absolute value of 2 is 2. The absolute value of -3 is 3. So whatever it is, we just make it positive. So absolute value equations, we're sort of doing the same thing. Some equations contain absolute value expressions, and we're going to use that definition to solve these equations. So a and b are real numbers, and b has to be greater than 0. So the absolute value of a is going to equal b. This means that we have two separate situations we should think about. We have to think about where a is positive, in which case a is just equal to b. And then we have to think where a is negative, in which case a is equal to -b, because either one of those are going to give positive b as their outcome. It's also important to note that since the absolute value of a number is always positive or 0, an equation like absolute value of x equals -5 is never true. So it has no solution. So if you end up with an absolute value of a variable is a negative number, the answer is the empty set. There are no numbers that you can put in an absolute value bar and get a negative as a result. So let's do an example. So we're going to solve the absolute value of x minus 18 is 5. So case 1, where we just take away the absolute value bars, we get x minus 18 equals 5. Case 2, we're going to take away the absolute value bars and make this negative. So we get x minus 18 equals -5. And then we're just going to solve like we regularly do. So we add 18 to both sides. We get x equals 23. Then over here in case 2, we're going to add 18 to both sides. And we are not going to get -23. We're going to get 13 because -5 plus 18 is 13. So yes, every single absolute value question will have two different answers. And yes, we do need to check and make sure these answers are correct. So the absolute value of 23 minus 18, does that equal 5? Yes, it does. The absolute value of 5 equals 5. Does the absolute value of 13 minus 18 equal 5? Yes, it does. Because the absolute value of -5 is 5. Great. Solving a multi-step absolute value equation. So here we go. So the first thing we have to do is isolate this absolute value part by itself first, and then rewrite it as case 1 and case 2. So first thing we're going to do is go farthest away. So we're going to add that 1 to both sides. So we get 3 times the absolute value of x plus 2 equals 9. This is 3 times the absolute value, so we're going to divide both sides by 3. And we get absolute value x plus 2 equals 3. Now we can do case 1, where we just take away the absolute value bars and we get x plus 2 equals 3. Then we can do case 2, where we take away the absolute value bars and make it -3. Then we're just going to solve and see what we get. So we subtract 2 from both sides, we get x is 1. Subtract 2 from both sides, we get x equals -5. Now we should check our answers. You always want to check your answers because sometimes they won't work. So you put them back into the original equation, and we find out that yes, that one works. Then we put the -5 back into the original equation, And we find that, yes, that one also works. Absolute value inequalities. This right here is very important. You're going to want to make some way of noting this in your notes because you will use this as a reference. So really, you really want to make sure that you note this. It's very important. If you don't want to note it, then you can memorize it. But noting it might be easier. So just once again, note that. Okay, so we have an example. We're going to solve the absolute value of 3x minus 12 is greater than or equal to 6. So greater than or equal follows this line right here. So that means that means 3x minus 12 is greater than or equal to 6. Or, because this is an or, 3x minus 12 is less than or equal to negative 6. We have case 1 and case 2. So let's solve each one. So we add 12 to both sides. We get 3x is greater than 18. Divide by 3. We get x is greater than or equal to 6. Then we look at the other side. We add 12 to both sides. We get 3x is less than or equal to 6. Divide by 3. We get x is less than or equal to 2. Okay? So then we're going to graph our solution. So we have a closed circle on 6, and it's the numbers greater than or equal, so it goes this way. Then we have to find 2, and we put a closed circle on 2, and it's going the other direction. All right, here's another example. Solve the absolute value of 4k minus 8 is less than 20, and graph the solution. So if you look at that part that we noted, 4k minus 8 absolute value is less than 20 is equal to negative 20 is less than 4k minus 8, which is less than 20. This is an and. And now we can solve both parts at the same time. Whatever we do to this part, we're going to do to this part and this part. So we add 8. Then we add it to both sides. So we get negative 12 is less than 4k is less than 28. Then we have to get rid of this 4, so we divide by 4 on all three parts. And we get negative 3 is less than k is less than 7. So here we go. We're going to graph it. Note there's no extra ink under the inequality, so they're going to be open circles at negative 3 and 7. And see how k is between negative 3 and 7? It's an and, so it's the intersection. It's going to be between. That's it for today. Have a great afternoon.